Okay, we're going to start the next unit, linear equations in systems, and we're going to look at the first lesson today, slope y-intercept form. So the first thing it says is we want to investigate what happens when we look at an equation such as equation A here, and it says rearrange each of the following equations into the form y equals. What does it mean to do that? That means we basically want to isolate y. Okay, we're isolating y. And then it says complete the table of values and graph the equations. Find and label the y-intercept on each line and find the slope of each line. So in order to isolate y, what I need to do is I need to get every other term by itself. So I want to keep the y by itself there. And what I want to do then, I'm going to take the negative 3x and I'm going to move that over my equal sign. And when I do that, we get a plus 3x. So now our equation looks like this. Y equals, and I'm going to put my positive 3x first and my minus 2 second. That's the same exact thing, right? I know that 3 minus 2 is the same exact thing as negative 2 plus 3, right? Those are both equal to positive 1, okay? So when I rewrite my equation, I've got y equals 3x minus 2. I want to then plug these little values in. So when y is equal to negative 2, when x is equal to negative 2, I should say, I get y is equal to, that's negative 6 minus 2, which is negative 8, okay? And when y is equal to, let me just squinch this over here. We'll just do this on the side, okay? When y is equal to negative 1, I keep saying y, I mean x. When x is equal to negative 1, I get 3 times negative 1 minus 2, which is negative 3 minus 2. So y would be equal to negative 5. Okay, and let's do one more here, and then we'll see the pattern quite clearly. When x is equal to 0, 0 minus 2 is negative 2. So of course, if I see the pattern here, negative 8 to negative 5 to negative 2, I think probably you can see that we're adding 3. Negative 8 plus 3 is negative 5, plus 3 is negative 2, plus 3 will be positive 1, and plus 3 will be positive 4. So you guys know, because we've talked a little bit about this, because the differences over here in the x are the same, okay, we're adding 1 and adding 1, and the differences here, our slopes would be the same throughout this line. So let's draw, there's going to be a continuous pattern. Let's draw this line now. When x is negative 2, y is negative 8. Okay, those are the points, negative 2, negative 8, the coordinates. Negative 1, negative 5. 0, negative 2. 1, 1, and 2, 4. Okay, so there's our line. I'm going to draw the line. And once we have our line, then we want to label, it says the y-intercept, and find the slope of each line. So let's find the y-intercept. Looks like our y-intercept is right here, because of course this is our y-axis. Okay, here's our y-intercept of negative 2. Okay, and our slope, if we use a couple of points that we have on the line, we can tell our slope is rise of 3, run of 1. Rise of 3, run of 1. Rise of 3, run of 1. 3, we can say 3, or we could say 3 over 1, which we know is the same thing as 3. Okay? So if we look at our equation, if I look at the equation here, right away I can see my y-intercept was negative 2 here. And look at the equation. There's a negative 2 constant, right? There's no variable there. And I know my slope here is 3. And look at our slope. Look at our 3 in front of our x. So it looks like there might be a connection there. Let's try one more question. We'll see if we're right. Okay? So we're going to change 4x plus 2y equals 8 into y equals form. So let's do that. We're going to move over, right? We have to isolate the y is the whole idea here. So we're going to move over the 4x. So now we've got 2y left on the left-hand side and negative 4x plus 8 now on the right-hand side. And the last thing we need to do to isolate y is to divide everything through by 2. So if we divide everything through by 2, we get negative 2x plus 4. okay? Let's plug our x values into our equation. So when x is -2, we get -2 times -2 plus 4, which is positive 4 plus 4, which is 8. So we have the -2, 8. When x is -1, we get y equals -2 times -1 plus 4, which is 2 plus 4, which is 6. When x is 0, we get y equals -2 times 0 plus 4. And it looks like we get the value 0 and 4. And I can see right away then the pattern is subtract 2, subtract 2, subtract 2, and subtract 2. So our next value is 2, and our final one is 0. So let's plot these points, okay, just like we did above. I'm going to plot the points -2, 8. And we get -1, 6, 0, 4, 1, 2, and 2, 0. So again, we've got a nice linear function because all of our lines seem to have the same sort of, they're all a pattern, right? Our steepness is the same. And what's our y-intercept of this particular graph? Well, if I look here, our y-intercept is right here. We've got y equals 4, okay? Our y-intercept is 4. If we wanted, we could put the actual coordinates there, 0, 4. But remember, there's our y-intercept. There's our y-axis, I should say. So our y-intercept is 4, and our x-axis. Our slope, okay, if we look at the points that we have, we're going down to right 1, down to right 1. And that made sense because our change in y is -2, and our change in x is +1, +1, +1. So, right, slope is rise over run. So we're falling 2 and we're running 1, right? There's our slope. And it's a -2 over 1, okay? Or just -2, okay? Which is the same thing as -2 over 1. And let's look at our formula again, or the equation. And it looks like that slope of -2 is right there in front of the x where we kind of thought it would be. And it looks like we have this y-intercept of 4 is right there. That's the constant on its own. So I think we can probably see that if we have our equation in the form of something x plus something, this first something here in front of the x is the slope, and this last constant by itself, okay, is the y-intercept. And what we say in math is we call this y equals mx plus b form. So this is y equals mx plus b form, where m is our slope and b is our y-intercept. Okay? How's the y-intercept? The y-intercept is actually the slope, I guess you could say, is the slope is the coefficient of x. Okay, the number in front of the x term and of the x variable. That's our coefficient there. And how's the y-intercept? The y-intercept is the constant. Okay, but it has to be in this form. So for example, if I see something like 2x plus 3y equals 12, this 12 here is not, that is not the constant y-intercept. That's not the y-intercept, okay? It has to be in slope y-intercept form, okay? The reason for that is this is not y equals mx plus b form, okay? So therefore, in order to find that slope and y-intercept, we always have to change our equation to y equals mx plus b form. And of course, this very first one, there's our slope, our coefficient of x, and our b value is our y-intercept. Okay, that constant. So let's look at the next couple of examples here. Okay, so we've got y equals so it says here, state the slope and the y-intercept for each line using the equation and graph the line using the slope and y-intercept. So if this is already written in y equals mx plus b form, then we can just glean the slope and the y-intercept right from that equation. So let's just double check. Is it written in that form? We've got y, Okay, we've got y here, and we've got a number in front of x plus a number, a constant by itself. So it certainly is written in y equals mx plus b form. So that means right away I know that this value here is my slope, and I know that this value here is our y-intercept. So I'm going to write that in. Let's just fill that in here. We know that our slope is -2/3, and I'm not sure 100% why we use m for slope. I think s might be for speed, so I think m is for slope. I'm not really sure. It's kind of always been a mystery. B is equal to 3. That's our y-intercept. And again, b, why do we use b for 3? I don't know. Why do we use b for y-intercept? But in our formula, we call it mx plus b, but m just means our slope and b means our y-intercept. So now that we have those two values, I know that we've done a little bit of this in class already, or in the last couple lessons, in the last unit rather, that we can find and draw a line given the slope. So remember, this is our rise over our run. So our rise is -2 and our run is 3. So we know automatically when our slope is negative, we know our line's it's gonna fall to the right. So I want to start with 3. That means our y-intercept is 3. That means x is 0 when y is 3, if we want to kind of really think that through. So I'm going to come over here in my graph, and I'm going to find when x is 0, y is 3. There's our y-intercept right there. And we practiced in the prior unit how to draw lines using any point. So now we've just got a specific point. We started at a specific point, 0, 3, and then we're going to fall down 2 and run 3. Down 2 and run 3. And here's a couple of points on our line. If we had to, we could go left 2 and up 3, or sorry, left 3, I should say, and up 2. Okay, but again, our pattern from left to right is down 2, right 3, down 2, right 3. So there we go. There's our line, and there's the equation. There's the line of the equation, y equals mx plus b. There's our x-intercept, and there's our y-intercept. Okay? Why don't I give you guys a chance to try? Well, we'll do one more together, and then you guys can try this one. Okay? Let's look at the next one. We've got y equals mx plus b. So our slope is this value, and our b value is 2. So our slope is -3, and our b, which is our y-intercept, is +2. Okay? So let's start with that y-intercept, because we need to start with a point. That's 0, 2. So let's find that on our graph. 0, 2, right here. And once we know that point, our slope is -3. So that's a -3 over 1. We're going to go down 3 and right 1. Down 3 and right 1. We've got another negative sloping line. And it's really just that simple. Once you know one point on the equation, on the line, then you've got the equation, and then you can use your slope to find the other points. And there's that y equals -3x plus 2. Okay? Why don't I pause the video, or why don't you pause the video rather, and you can try the next one. And if you want, you could even try the next one after that. But you try this one right here and see if you can get that answer. Okay, so I've drawn that line. Our slope was 2, and our y-intercept is 0, -1. Okay, that's right there. That's 0, -1. When x is 0, y is -1, right? We're crossing that. Just a reminder, we're crossing the y-axis. Okay, that's our y-axis there, that big blobby green line. We probably don't need to make it that thick, but there's our y-axis. Okay, so it crosses right there at 0, -1. Now the next one looks a little tricky. If I think about y equals mx plus b, okay, this one looks kind of special. What's our b value there? There's nothing there. So of course, if there's nothing there, we know that that's equal to 0, right? There's a little missing 0 there. That means that we've got a slope of 4/5, okay, and our y-intercept, our b value is 0, which means our origin is where the graph intersects the y-axis. Okay, it's 0, 0, and we go from 0, 0. We're going to rise 4 and run 5. Okay, and rise 4 and run 5 if I wanted one more point. And there would be another point. And again, if we wanted to go in the opposite direction, we could fall 4 and go 5 to the left. But from left to right, again, we're always going up 4 over 5, up 4 over 5, and so on. Okay, let's connect those points. And there's our line, y equals 4/5 x. Okay. For the next example, it says write the equation of a line passing through the point 0, 4 with slope 7, 2. So if x is 0 and y is 4, I know, as soon as I know that x is equal to 0, okay, then that's the y-intercept, okay? So in our slope, there's our m value. M is 7 over 2. Our b value is 4. So to write that, we would just write 7 over 2x plus 4. There's our equation. We're just going backwards. We've got the information. They're saying put it back into equation form. Okay? Consider the graph on the right. What are the slope and y-intercept of that line? So we're going to look at this. I can see my y-intercept is 0, 1. Okay? The y-intercept is 0, 1. And the slope, where I'm going to pick values that I know are right nicely on the grid, aren't I? So like this point here would not be a good point to choose, right? Because it's not right perfectly on the grid. I don't know the coordinates. I can see that that 6, -3 looks like it's right on the grid. And I think that 3, -1 is right on the grid. And if I just erase this up here, I can see that -3, 3 is right on the grid. And I can see the pattern right away when I pick those nice numbers, that the pattern is down 2, right 3. Down 2, right 3, down 2, right 3. Remember, we always rise or rise first. So if it's negative, we're going to go down, right? And we're writing right 3. Down 2, right 3. Okay? So our slope is -2 over 3. What is the equation in slope y-intercept form? It would be y equals -2/3 x plus 1. Okay, we're just putting those values in where they belong. Okay, our b value there is 1. And the last thing here says use a graphing calculator. Using a graphing calculator, sketch the graph and complete the table for the equation. So I have a graphing calculator on my iPad. I don't have the TI, it doesn't download nicely for me. I even tried buying it, it didn't work. So I can just use the one that we have. In class, we would probably use the TIs if students needed that practice. So let's grab your calculator if you've got it. If you don't, you can follow along and you can see how we'll do that, okay? Okay, we're going to use the graphing calculator that I have on my iPad, and we're going to graph y equals -45/2 x plus 30. Let me just clear this. So pretend we're not in here. You get your calculator out. The very top buttons are the graphing buttons. So I'm going to go to y equals, and I'm going to graph y equals 45 divided by 2 x, and the x key is simply below the mode key where you see the x, t, etc. there. I just touched it again. And that was a plus 30. And now if I push graph, okay, my calculator can show me some things. I can't see the y-intercept here, so if I wanted to make it so that I could see the y-intercept as well as the x-intercept, I can go into my window. And in my window setting, I just want to move my graph. If I look at my graph, I want to move so I can see farther up on my screen. So I'm going to go into the window setting, and I'm going to move that graph window setting up. I know my y-intercept is 30, so maybe I'll just change it to like 40. And then I can push a graph, and there I can see my x-intercept and my y-intercept. Okay, so that's a really nice clear graph there. So I changed my window settings slightly. The standard window is from -10 to 10 on the x and -10 to 10 on the y. So we will practice that a little bit more going forward, and hopefully you have a graphing calculator at home. So here our slope was -45 over 2, okay, because of course that's in y equals mx plus b, and our y-intercept here was 30. And our window, and if I kind of graph, it kind of looked like that, something like that. And there was our equation, and here's our y-intercept of a 30 right here. And in order to see that y-intercept, initially our standard window was at -10, okay, 10. Our scale was 1, -10, 10, and our scale was 1. But we changed this y max here. We changed the y max so that we could see farther up, because our y value, it was initially 10, which we would have only seen up to that point right there. So we changed that to a positive 30, okay? And then the next question here says, determine the x and y intercepts for the above equation algebraically. Well, of course, if I want to find my x-intercept, I let y equal to 0. And if I want to find my y-intercept, I let x equal to 0. And actually the y-intercept is super easy because I can see that it's 30. And watch this, y equals -45 divided by 2 times 0 plus 30. Well, that's in fact y. This is our y-intercept right here, isn't it? When anything times 0 is equal to 0, that's like y equals 0 plus 30. So y is equal to 30. And we knew that, okay, because we've got our equation there. The other, finding the x-intercept, letting y equal to 0, we're going to say 0 is equal to -45 over 2x plus 30. We're going to subtract 30 from both sides. Okay, now I've got -45 over 2x. Now, of course, I can just rewrite that as -45x over 2 because I'm just multiplying these two fractions. So this is just the same as -30 over 1 is -45x over 2. Now I've got a proportion, so the easiest way to solve a proportion is to cross multiply. So we go -45x times 1 is -45x, and -30 times 2 is -60. And when we divide both sides by -45, 60 divided by -45, I believe that is divide by 15, so that's -4/3. Okay, -4/3. As a decimal, that would be -1.3 repeating. Okay, so that would be right here, -1.3. Okay, and so there we have it. And for the assignment, I would do numbers 1 to 6, okay, for sure lesson 1 to 6, and number 7 if you have a graphing calculator, okay. If you have a graphing calculator and you're able to do number 7, do so. If not, then we can always do that. We'll try to cover that a little later, okay? It's a little bit difficult to do that from home. So good luck, and please contact me if you have any questions. Thank you.